A flowchart is a type of diagram that represents an algorithm, workflow or process, showing the steps as boxes of various kinds, and their order by connecting them with arrows. This diagrammatic representation illustrates a solution model to a given problem. Flowcharts are used in analyzing, designing, documenting or managing a process or program in various fields. Overview. Flowcharts are used in designing and documenting simple processes or programs. Like other types of diagrams, they help visualize what is going on and thereby help understand a process, and perhaps also find flaws, bottlenecks, and other less obvious features within it. There are many different types of flowcharts, and each type has its own repertoire of boxes and notational conventions. The two most common types of boxes in a flowchart are a processing step, usually called activity, and denoted as a rectangular box, a decision, usually denoted as a diamond. A flowchart is described as cross-functional when the page is divided into different swim lanes describing the control of different organizational units. A symbol appearing in a particular lane is within the control of that organizational unit. This technique allows the author to locate the responsibility for performing an action or making a decision correctly, showing the responsibility of each organizational unit for different parts of a single process. Flowcharts depict certain aspects of processes and they are usually complemented by other types of diagram. For instance, Kaoru Ishikawa defined the flowchart as one of the 7 basic tools of quality control, next to the histogram, Pareto chart, check sheet, control chart, cause and effect diagram, and the scatter diagram. Similarly, in UML, a standard concept modeling notation used in software development, the activity diagram, which is a type of flowchart, is just one of many different diagram types. Nasse-Schneiderman diagrams and Dracone charts are an alternative notation for process flow. Common alternative names include flowchart, process flowchart, functional flowchart, process map, process chart, functional process chart, business process model, process model, process flow diagram, workflow diagram, business flow diagram. The terms flowchart and flowchart are used interchangeably. The underlying graph structure of a flowchart is a flow graph, which abstracts away node types, their contents and other ancillary information. History. The first structured method for document process flow, the flow process chart, was introduced by Frank Gilbreth to members of the American Society of Mechanical Engineers in 1921 in the presentation, Process Charts, First Steps. In finding the one best way, Gilbreth's tools quickly found their way into industrial engineering curricula. In the early 1930s, an industrial engineer, Alan H. Mogensen, began training business people in the use of some of the tools of industrial engineering at his work simplification conferences in Lake Placid, New York. A 1944 graduate of Mogensen's class, Art Spinonja, took the tools back to Procter & Gamble where he developed their deliberate methods change program. Another 1944 graduate, Ben S. Graham, director of Formcraft Engineering at Standard Register Industrial, adapted the flow process chart to information processing with his development of the multi-flow process chart to display multiple documents and their relationships. In 1947, ASME adopted a symbol set derived from Gilbreth's original work as the ASME standard, operation and flow process charts. Douglas Hartree in 1949 explained that Hermann Goldstein and John von Neumann had developed a flowchart to plan computer programs. His contemporary account is endorsed by IBM engineers and by Goldstein's personal recollections. The original programming flowcharts of Goldstein and von Neumann can be seen in their unpublished report, Planning and Coding of Problems for an Electronic Computing Instrument, Part 2, Volume 1, which is reproduced in von Neumann's collected works. Flowcharts became a popular means for describing computer algorithms. The popularity of flowcharts decreased in the 1970s when interactive computer terminals and third-generation programming languages became common tools for computer programming. Algorithms can be expressed much more concisely as source code in such languages. Often pseudocode is used, which uses the common idioms of such languages without strictly adhering to the details of a particular one. Nowadays, flowcharts are still used for describing computer algorithms. Modern techniques such as UML activity diagrams and dracone charts can be considered to be extensions of the flowchart. Types of flowchart. Sternekert suggested that flowcharts can be modeled from the perspective of different user groups and that there are 4 general types. Document flowcharts, showing controls over a document flow through a system. Data flowcharts, showing controls over a data flow in a system. System flowcharts, showing controls at a physical or resource level. Program flowchart, showing the controls in a program within a system. Notice that every type of flowchart focuses on some kind of control, rather than on the particular flow itself. However, there are several of these classifications. For example, Andrew Veronis named 3 basic types of flowcharts: the system flowchart, the general flowchart, and the detailed flowchart. That same year, Marilyn Bowles stated, "In practice, 2 kinds of flowcharts are used in solution planning: system flowcharts and program flowcharts." More recently, Mark A. Freeman stated that there are more differences. Decision flowcharts, logic flowcharts, systems flowcharts, product flowcharts, and process flowcharts are just a few of the different types of flowcharts that are used in business and government. In addition, many diagram techniques exist that are similar to flowcharts but carry a different name, such as UML activity diagrams, flowchart building blocks. Common shapes. The following are some of the commonly used shapes used in flowcharts. Generally, flowcharts flow from top to bottom and left to right. Other shapes. A typical flowchart from older basic computer science textbooks may have the following kinds of symbols. Labeled connectors represented by an identifying label inside a circle. Labeled connectors are used in complex or multi-sheet diagrams to substitute for arrows. For each label, the outflow connector must always be unique, but there may be any number of inflow connectors. In this case, a junction in control flow is implied. Concurrency symbol represented by a double transverse line with any number of entry and exit arrows. These symbols are used whenever 2 or more control flows must operate simultaneously. The exit flows are activated concurrently, when all of the entry flows have reached the concurrency symbol. A concurrency symbol with a single entry flow is a fork, one with a single exit flow is a join. Dataflow extensions. A number of symbols have been standardized for dataflow diagrams to represent data flow, rather than control flow. These symbols may also be used in control flowcharts. A document represented as a rectangle with a wavy base. A manual input represented by quadrilateral, with the top irregularly sloping up from left to right. An example would be to signify data entry from a form. A manual operation represented by a trapezoid with the longest parallel side at the top, to represent an operation or adjustment to process that can only be made manually. A data file represented by a cylinder. Software. Diagramming. Any drawing program can be used to create flowchart diagrams, but these will have no underlying data model to share data with databases or other programs such as project management systems or spreadsheet. Some tools offer special support for flowchart drawing. Many software packages exist that can create flowcharts automatically, either directly from a programming language source code, or from a flowchart description language. Online web-based versions of such programs are available. There are several applications that use flowcharts to represent and execute programs. Generally, these are used as teaching tools for beginner students. These include Flowgorithm, Raptor, LARP, Visual Logic, Rule, Logical Scheme Compiler,